Hello dear students. So today we are going to discuss about salts containing oxoanions of metals. There are two oxoanions. First one is potassium dichromate. In this video we will discuss about preparation, properties and structure of potassium dichromate. So potassium dichromate is K2Cr2O7. This is very important compound as it is useful in leather industry as well as in organic chemistry as oxidizing agent. Preparation. So dichromates are generally prepared from chromates. So the important points are dichromates and chromates, which in turn are obtained by fusion of chromite ore. Chromite ore is FeCr2O4. It can be written as FeO dot Cr2O3. So this is chromite ore. This is how we can represent this another way. So chromite ore is fused with sodium or potassium carbonate, okay, with excess of air. Now the reaction is given. This is chromite ore with sodium carbonate and in excess of air. Do remember the equation. You have to remember the equation along with the balanced equation. The balancing has to be done. So just learn it carefully. So it will result in the formation of sodium chromate. 8 moles of sodium chromate and 2 moles of ferric oxide and 8 moles of CO2. Right? So the first step is, that is, fusion of chromite ore with sodium carbonate or potassium carbonate in excess of air, right? Then yellow solution of sodium chromate is formed. So this sodium chromate which is formed, it will be yellow in color, and it is filtered, and then in next step it is acidified with sulfuric acid to give a solution from which orange sodium dichromate, now Na2Cr2O7.2H2O, can be crystallized. So crystal formation of sodium dichromate takes place by treating sodium chromate with sulfuric acid. Okay, so this will form the second step for the preparation. This is sodium chromate in acidic medium. H positive ion means acid. It will result in the formation of sodium dichromate and sodium sulfate or something that will be formed. Salt is formed and water, right? This is the step number 2. So the first step was by treating this chromite ore with sodium carbonate or potassium carbonate. As a result, sodium chromate is formed. Then in second step, sodium chromate is acidified and it is converted into sodium dichromate. This sodium dichromate so obtained is more soluble than potassium dichromate, and the latter is therefore prepared for by treating the solution of sodium dichromate with potassium chloride. So this will form the step number 3, that sodium dichromate which is obtained in step 2, that will be treated with potassium chloride to form potassium dichromate along with sodium chloride. So finally we will obtain orange crystals of potassium dichromate. Is it clear? So these are the 3 important methods of preparation, and you have to remember all the 3 steps. Then chromates and dichromates, they can be converted. They are interconvertible depending on the medium. If the medium is acidic, so chromate ion will be converted into dichromates. Chromate ion. Okay, you have to remember this. Chromate ion and then dichromate ion is Cr2O7 2 negative. Okay, the oxidation state in both these is +6. Oxidation state of chromium will remain same. But how they are interconvertible? When chromate ion is acidified, it will result in dichromate ion formation, and when dichromate ion is treated with a base, any alkali, so this will result, or it will give back chromate ion. This is again important, that change in pH can affect the formation or can change the preparation of the various or two ions. Now the structures of chromate ion and dichromate ion, as you can see that the chromate ion is yellow in color, whereas dichromate ion is orange red. So on the basis of coloration you can predict chromate ion. Again the hybridization is sp3, that is chromium is sp3 hybridized in both the cases, but in chromate there is only one central atom, whereas in dichromate there are two central atoms, and the two are separate, two oxygen atoms. One oxygen atom is common, which is separated by 126-degree angle. Okay, so the structure is important. Both are sp3 hybridized and tetrahedral. This is also tetrahedral, but two tetrahedral are bonded in such a manner that the bond angle between these two bonds, this and this, is 126. Then bond length is given, that is chromium and this central oxygen bond length is 179 picometer, whereas that of chromium and other oxygen atom is 163. Right, now the properties of sodium or potassium dichromates. So sodium and potassium dichromates are strong oxidizing agents. These properties are the most important one, that they act as oxidizing agents. Sodium salts has greater solubility in water, and is because sodium salts are soluble in water and therefore extensively used as oxidizing agents in organic chemistry. When we will discuss organic chemistry, we will come across these compounds. Potassium dichromate is used as primary standard solution in volumetric analysis. This will be doing in titration. I think titration you have done in +1, but in +2 basically there will be potassium permanganate, but it can be used as standard solution. Okay, primary standard solution for volumetric analysis. Now the most important part, it's oxidizing action. So the main equation for oxidizing nature of potassium dichromate is this equation: dichromate ion in acidic medium, it will gain 6 electrons. As a result, from +6 oxidation state, it will be changed to +3 oxidation state. So itself it undergoes reduction, whereas it can help in oxidation of other species, +7 water molecules. This equation I think you have balanced in +1 in redox reactions, half equation method. So this is important reaction. This is how it can act as, by gaining electron, it will act as oxidizing agent. On the basis of this, the E0 value is given 1.33 volt. Thus it can oxidize. Now 4 reactions are given. These 4 ionic equations are important. Iodides to iodine. As you can see in first equation, there's 6 iodide ions, they are changed into iodine +6 electrons. In the same manner, sulfides to sulfur. So as in this second equation, H2S gives 6H positive plus 3 sulfur atoms. So H2S, in H2S sulfur has -2 oxidation number and it will be changed to 0. So from -2 there is increase in oxidation number. As a result, we say that it undergoes oxidation. So this oxidation process is carried out by dichromate ion. In the same manner, tin 2 to tin 4 and iron 2 to iron 3, that is ferrous to ferric, as you can see in these both the reactions. So do remember these reactions with balanced equations. Now the final equation for oxidation of ferrous to ferric is given. This is by combining half reaction, this reaction and this one. So we will get this equation: dichromate ion 14H positive 6Fe2 positive will result in the formation of Cr3 positive and ferric as well as water. The same equation has already been discussed in +1. Okay, so these are the main properties of dichromate ion, or we can say potassium dichromate.